Okay, part two. So this time we're going to talk about ionic nomenclature for metals that have more than one possible charge. So here's the example. Copper can have a +2 charge, or it can have a +1 charge. And so if I have copper paired with the chloride ion, I have two possible scenarios. I can have the copper with the +2, and then that subscript of 2 for the chlorine is what would identify that +2 charge on the copper, and then the 1 under the copper, or the assumed 1, you don't need to put, or you're not supposed to put, 1 subscript when that's what the subscript would be. And that comes from the -1 on the chloride ion. And then here, where I have CuCl in just a 1-to-1 ratio, since chloride ion is always a -1, it's a halogen, the halogens are always -1, then the copper must be a +1. So the way that that's indicated, or the way you distinguish between the two, is by using a Roman numeral. So in this case, since the charge on the copper is a +2, I use a Roman numeral of 2 in the name in between the metal and the non-metal. And then here, since the charge on the copper is a +1, I'd use the Roman numeral 1 there. So if the metal, and they're transition metals, has more than one charge, so there's a chart that I have posted here in the content that has a number of them. You can find all of the ones that have the Roman numeral on the internet if you just look it up. Okay, so if it has more than one charge, then you must indicate that charge in the written name. So where you're going to, we'll see this in a couple of my examples down here as well when I start talking about polyatomic ions. So this nomenclature here is exactly what we talked about in the previous segment, but now you just have to be careful. You have to know, is it possible that this metal has more than one charge? And there are quite a few of them that have more than one charge. And if that's so, you must indicate with a Roman numeral. Okay, so then we're going to look at the ionic nomenclature with polyatomic ions. And so what is a polyatomic ion? Polyatomic ion is just a combination of two nonmetals that come together and leave a charge. And typically they have oxygen in them. Not all of them do, but most of them do. And so if we're to name a metal with a polyatomic ion, and the polyatomic ions always have, I said always, but that's not necessarily true, most of the time have a negative charge. There is one that has a positive charge, and it's the ammonium ion, which is NH4 with a +1. Honestly, I don't think you'll run into any others, at least in this course, besides the ammonium that has a positive charge. Okay, so let's go to a formula with a polyatomic ion. So BaSO4, barium sulfate. So why is it barium sulfate? Well, the Ba is my metal with a +2 charge. The sulfate is SO4 with a -2 charge. They're going to pair up in a 1-to-1 ratio. I wouldn't necessarily use the parentheses here, but that's where a parenthesis would go if we had to have a parenthesis. And I'll talk about that in just a minute. So barium sulfate, all you have to do is use the name of the metal straight as it is stated, and the name of the polyatomic ion, sulfate. Again, if you look in the content folder for this week, you'll find a list of common polyatomic ions. Typically, you'd have to memorize them, but since you guys get to have all your resources right with you, you won't have to memorize them. So another example, sodium chromate. So sodium's a +1. It comes from the first group. The chromate ion, I'd look it up on my list of common polyatomic ions. It has a -2. I just circle the whole polyatomic ion because it's that whole unit that has the -2 charge. And then you do your crisscross, as I show here, and you get Na2CrO4 as your formula for that. And then another nice example is this strontium chlorate. Strontium's a +2 from the second group. The chlorate ion is a polyatomic. It has a -1 charge. So if I do the crisscross, then I see that I have to have 2 of the chlorate polyatomic ions. And the way to indicate that is with a parenthesis. So if you have more than one of the polyatomic ion, you have to include parentheses. And if you don't, if it's just a 1-to-1 ratio, because that would be a 2-to-2 ratio, but you reduce it to 1-to-1, you don't have to use the parentheses there. And then an example where we have a polyatomic ion with a transition metal that has more than one charge. If I look up iron, so when you have, when you're doing a nomenclature and you have a metal, the first thing you want to do is look and see, is it a metal that has more than one charge? Do I need to use a Roman numeral or not? And if it's a transition metal, you probably have to, but not necessarily. You really have to look it up and see if it has more than one charge. So we know that iron has more than one charge, therefore a Roman numeral is needed. So I would look at my formula here. This is going the opposite way than I did up here. And I know that the formula is Fe2 parenthesis SO4 3. So that 3 that's outside the parenthesis comes from the iron charge, which would have to be a +2. It's a metal. Metals form positive charge. And then the 2 here becomes the -2 charge on this polyatomic ion. And if I weren't sure, I would just look up to make sure that that SO4 is a -2 charge. But it sure looks like it based on this 2 here. So then I know I'm going to have to use a Roman numeral, but I use the Roman numeral that indicates the charge, okay, not the subscript. So I wouldn't use a 2 in here. I use the 3 due to the charge. So it's iron 3 sulfate. I'm going to stop there.